Assalamualaikum and a very warahmatullahi wabarakatuh. My name is Muhammad Zikrata Muhammad Azri and I'm from Group 8. So today I will present about semiconductor IC fabrication. So we will explore the fabrication process in IC technology. So today we will focus to introduction on IC, fabrication process that involve, explanation on each process, and summary and conclusion. So my part here were, my part here were semiconductor, the importance of understanding on semiconductor fabrication IC process. So the semiconductors are those materials whose conductivity and resistivity lie between conductors and insulators. In general, a semiconductor is a device that allows current flow for an applied voltage. And fabrication is a process of constructing an industrial product. We can also define it as a set of methods to manufacture an electronic device or product. The semiconductor fabrication process is a complex and highly specialized series of steps that transform raw materials into functional electronic components. And so by the end of the lesson, we will be able to describe on how fabrication process is and name at least three process of fabrication that involve and explain what happened in each fabrication process and different process and how it done. So on the first process, we call it as a crystal growth, and the growing of a single crystal Si from fine granulate of Si EGS under controlled doping of impurities at the temperature between 1000 degrees Celsius. All processes used to grow semiconductor crystals operate at high temperature in aggressive environments known as the Shizokralski method. Many semiconductors are made of silicons. This metallite is grown into single crystals, sliced into a 1 millimeter thin wafer, and finally processed into tiny microelectric system. So this is the Shizorowski method, the diagram, and we go to the Shizorowski process, or CZEC, is also known as crystal pulling or pulling from the melt. So in this process, silicon Si is first melt and then allowed to freeze into crystalline state in a controlled manner. The advantage of this method is that it is fast and highly controllable. So in order to control the convective heat and species transport in the melt, including the shape of the solid liquid interface, which plays one of the most dominant roles in terms of the crystal quality. A proper combination of crystal and cubical rotation is used during the whole process. So, sorry. So next, we go to the oxidation process. So the process of a silicon wafer is a crucial step in the production of semiconductor device. This process is employed to create an insulating layer of silicon dioxide of water surface in order to protect and isolate the subsequent electronic component. So the resulting silicon dioxide layers layer X as an excellent insulator, preventing the flow of electrical current through the wafer's surface, and this insulation is crucial for the proper functioning of the subsequent process, such as deposition of the metal or the creation of transistor structure. So as we see in the diagram here, so the wafer with the outside film was formed, same as this diagram. So on the oxidation process, they also have one process called thermal oxidation. So on the thermal oxidation is the most common method of oxidation is thermal, and then we classify either of dry or wet oxidation. Wafer are loaded into the quartz molds and slid into the furnace heated to approximately 1,200 degrees Celsius. In dry oxidation, thin oxide layers are grown in environment containing oxygen and hydrogen chloride near from atmospheric pressure. Thicker oxide layer require high pressure and the use of the steam. Wet oxidation. Wet oxidation is performed by exposing the wafer to a mixture of oxygen and hydrogen in the furnace chamber. Water vapor is formed when the hydrogen and oxygen react. So the oxygen is led to the wafer in gaseous state and reacts at the wafer surface to form silicon dioxide. A film of the glass with amorphous structure is formed. Depending on the gases, different oxidation occur. Thermal oxidation has take place on the bare silicon surface, and the thermal oxidation can be divided into the dry and wet oxidation, while the latter can divide new into wet oxidation and the H2O2 combustion. So at this diagram, this is the oxidation, the thermal oxidation chamber. So we have exhaust gas and cap, quartz bolts, wafer, horizontal quartz tube, heating zone, the temperature controller, wet gas and dry gas. So that's all for my part. So my name is Muhammad Azhar Kabir Muhammad Azhari. So thank you so much.